Hello, my name is Untitled and my presentation is about the sacrificial anode rod versus the impressed current system. This presentation examines the use of sacrificial anode rod and impressed current systems in water heaters. These two mechanisms are used to prevent corrosion of the water heater tank, as the tank is usually made up of steel. Criteria is maintenance and installation costs, and the rate of corrosion, and the use of external power sources. Finally, we have a recommended mechanism, which is the sacrificial anode rod, as it provides easy maintenance and it is cheaper to replace. Table of contents, analytical framework. Then we look at the first mechanism, which is the sacrificial anode rod. Then we look at the second mechanism, which is the impressed current system. And finally, we have a concluding analysis and recommendation. The operational goal of these two mechanisms is corrosion prevention of domestic water heater tanks through lower costs and easy maintenance. The first criteria is maintenance and installation costs, and it is the technical skills required and the budget required to replace it. Criteria number 2 is the rate of corrosion, the year the mechanism needs to be replaced, and the lifespan of the tank. Criteria number 3 is the use of external power source. Does the mechanism use more electricity? Does it have a complex setup? And is more technical skills required? The first mechanism is the sacrificial anode rod. It's a metal rod that varies in color depending on the type of metal used on the steel core wire. Aluminium, magnesium, tin, and zinc are the most commonly used metals in these rods, and they range from sizes and lengths of 39 inches to 42 inches, and thicknesses from 5/8 inches to 21/25 inches. And here we have images of the sacrificial anode rod. On the left we see what the anode rod would look like after it has been used. On the right we see where the sacrificial anode rod is placed in a water heater tank. This image shows the components of the sacrificial anode rod. The machine threads allow the anode rod to be screwed into the water heater tank, while the cap seals it to the water heater tank. And then we have the steel core wire and the metal rod. The operation of this mechanism uses electrolysis, which is the natural flow of current and electrons between the anode rod and the water heater tank. Through this process, the anode rod is corroded away, while the water heater tank is prevented and protected from corrosion. Background. Alumax Extrusion Inc. claimed to be the original patent owner of the mechanism, and Richard Twigg claimed to be the inventor of the sacrificial anode rod. However, after further investigation, we see that the original patent owner and the inventor is unknown to this very day. The first application of cathodic protection can be traced back to 1824, when Sir Humphrey Davy, in a project financed by the British Navy, succeeded in protecting copper sheathing against corrosion from seawater by the use of iron rod anodes. The assessment of the sacrificial anode rod. Cost of replacing this mechanism depends on the type of metal used and the type of water heater used. The cost ranges from $19.96 to $52.69. There is no technical training required to replace the sacrificial anode rod. It can be done by any member of the household above the age of 18, and it needs to be replaced about once every 3 to 5 years. And the rate of corrosion of this mechanism is slow and steady. Now we look at the second mechanism, which is the impressed current system. The impressed current system, it consists of an unreactive impressed anode rod. Unlike the sacrificial anode rod, the impressed current system is not reactive. and it uses power cables and transformers to make it reactive. And unlike the sacrificial anode rod, it cannot be viewed for a better understanding of its components. And here's what it looks like once you cut away the water heater. You can see that the unreactive anode rod is placed at the bottom because it's connected to an electrical circuit. And the image on your right shows what it would look like. It would consist of a transformer, power cable, and the unreactive anode. And here is more of the components of the impressed current system. You have the unreactive anode connected to the transformer or rectifier through cable connections. Operation. The transformer provides the flow of current between the tank and the anode rod. It does not have a natural flow of current. Because of the transformer, there is a flow of current, but it's artificial. Anode rod does not corrode away in this particular system. It's just the source of electrons, the charge for corrosion prevention. When the water heater is switched on, the impressed current system is activated, and the rate of corrosion depends on the availability of electricity. Background. Like the sacrificial anode rod, the original patent owner and inventor of the impressed current system is unknown to this very day. Patent owners and inventors vary from design, function, and application of the impressed current system. The original experiment that brought about the development of the impressed current system was conducted by Sir Humphrey Davy. Assessment. Cost of impressed anode rod ranges from $238 to $240, and technical training is required when electrical technician is required to change the anode rod or even the circuitry. Replacement of the anode rod is after 12 years, but if the circuitry is damaged, a new water heater is needed. And the transformer provides a controlled rate of corrosion, and it uses external power sources where more electricity is required. The disadvantage of the system is it could bring about cathodic corrosion of aluminium and straight current corrosion and coating debonding. Now we have a comparison between the sacrificial anode rod and the impressed current system. The sacrificial anode rod provides lower maintenance cost and needs to be replaced after 3 to 5 years. It can be replaced by any member of the household above the age of 18, and it protects the water heated tank at a regular rate of corrosion. The impressed current system provides a high maintenance cost. The maintenance often is required on a regular basis. Replacement is usually done by an electrical engineer, but if the circuitry is damaged, a new water heater needs to be bought. Transformers are used in the impressed current system to control the rate of corrosion. Damage to the circuitry can also change the rate of the corrosion.